Alright guys, today I'm going to do a review of all the skills that we've learnt for quadratics and then introduce you to probably the highest year 10 math skill, but you'll realise that it's not actually too bad. So here's a quick review of what we've learnt so far. So we've learnt to expand and simplify. So x plus 3 in brackets times x minus 9 in brackets. We have the x times x times negative 9, the 3 times x, and the 3 times negative 9. So we know how to expand and we know how to simplify by collecting those like terms. I've got two more because this is quite a key skill. So x multiplied by x plus 2, x times x, and x times 2. And because x squared and 2x are, well, they're not like terms, we don't need to do any simplification. It's already simplified. I've got a harder one for us here. I've got 2x plus 3 multiplied by 5x minus 1. So 2x times 5x, 10x squared. 2x times negative 1, negative 2x. 3 times 5x, sorry, is 15x, and 3 times negative 1 is negative 3. So when we collect these like terms, 10x squared plus 13x minus 3. Excellent. So we learnt how to expand and get these into the general form of the quadratic equation ax squared plus bx plus c. What we then wanted to do is, like pretty much everything in mathematics, we wanted to be able to go in reverse. We wanted to be able to take this expanded form of the quadratic and get it back into factored form. We wanted to write it in terms of two factors. Now factors, remember, are two things that multiply to give a product. So for this one, 2x plus 3 times 5x minus 1. One factor is 2x plus 3, and the other factor is 5x minus 1. The same reason that 3 times 4 equals 12. 3 is a factor, and so is 4. Okay, so factorise. We want to write x squared plus 13x plus 36. This is a simple quadratic. We just want to write that in factored form. So we want to write it as multiplication of two terms, not the addition of three terms. So we needed two numbers that multiply to 36 but add to 13. So 4 and 9 work, and that's the only two numbers that they're going to work here. 4 times 9 is 36. 4 plus 9 is 13. So this is going to be written as x plus 4 and x plus 9. Because you can see that when we expand this out, we get 4 times 9 to give the 36. 4x plus 9x gives 13. So that's why these numbers add to 13 and they multiply to 36. We had two special cases of quadratic equations. We had difference of two squares, which factored out to be just x plus 8, x minus 8. And we had perfect squares, which would factorize out to be, if we have got x squared minus 10x plus 25, it came out to be just one bracket squared, because it's a perfect square in that case. So x minus 5 all squared. I then did a video on how to factorize when there was a common factor. So for the case of 2x squared plus 14x plus 24, each number or coefficient and constant had a factor of 2. So 2 could come out the front of all of this, leaving x squared plus 7x plus 12. Once that factor had come out the front, we then factorized what was left on the inside. So we've got 2 times x squared plus 7x plus 12, which in factored form was x plus 3, x plus 4. Again, they multiply the 12, they add to 7, and we've already taken the 2 out the front. Then we went through, this is the harder one, we went and we solved or factorized quadratics where there was no common factor. So an easy way to do that is to create a quadratic with a prime number, and it's very obvious that there's no common factor. So we had a kind of an algorithm for this, I suppose. So we take the first term, we multiply it by the last term, and we look at factors of 12 that are going to add to 13. So factors of 12 that add to 13, we got 6 and 2, I get 12 and 1. 12 and 1 add to 13 and multiply to 12. So that's what we did. We learnt how to split this 13 up into 2 parts, and then I put a line in just to help me with the factorization. So now I factorized the left hand side, so a 2 and an x can come out of both of those, leaving x plus 6, and I can't see anything being factored out of this, but I can always write a 1 as a factor. Now we can see that if I just wrote this as something more like 2xy plus y, right, you would factor the y out, wouldn't you? You'd take the y and you'd be left with 2x plus 1 once you factor the y out. Well, it's very similar here. We're just going to take the x plus 6 out. We're going to take that whole bracket and factor that out the front. X plus 6, 2x plus 1. And we learnt how to factor with that process. So that's just a review. So if I've gone a wee bit quick, it was just meant to review all the things that we've learnt in the past. And there is a video on all of this that I've already made for you guys. So this is still part of a review, because we then learnt how to solve quadratics. What we see here, we've got x plus 7 times x minus 3 equals 0. Now if two things multiply to 0, okay, that means that one of those things must be 0, because the only time that you get 0 after multiplication is if one of the factors is 0. So 12 times what? 12 times what equals 0? Well, obviously 0. And what times, say, 4 equals 0? 0. So if two things multiply to 0, so square times triangle equals 0, then either that square stands in for 0 or that triangle is 0. So for this one, x plus 7 equals 0 or x minus 3 equals 0. Well, solving this top one, we just subtract 7 off both sides. X is negative 7. This one we could add 3 to both sides. X is 3. And then you can see that the quicker way is just the opposite sign of these numbers is your solution. Let's look at a more tricky one. So obviously each bracket could equal 0. So 2x plus 1 equals 0. Or 3x minus 4 equals 0. So either this factor is 0 or this factor here is 0. Okay. Solving these just by linear equations, subtract 1 and divide by 2. There's our first solution. Add 4, divide by 3. There's our other solution. Our two solutions. So is there a quick way like this one? There is. Minus 1 over 2. Positive 4 over 3. That's the really quick way of solving those. So solving's actually fine. I think the hard part of any solving is actually doing the factorization. That's why we just focus on factorizing so much before we get to solving these equations. Okay, so let's look at one when it's not in factored form. So we have to factorize first. Okay, first of all, I look, there's obviously a number greater than 1 out the front, so I check, is there a common factor? Yes, there is, a 3. So once that 3 comes out, we have x squared plus 10x plus 25. Now I'm thinking numbers that multiply to 25 and add to 10. Oh, 5 and 5. So we have the same bracket twice, or 3 lots of x plus 5 squared equals 0. So 3 times something squared equals 0. That must mean that that thing that's being squared is equal to 0. Or x is negative 5. One solution for that one. So a bit of a pretender, right? It's pretending to be hard by having a common factor, and it's a perfect square. So I just wanted to use that example because I wanted to just bring in, you know, a little bit of this, a little bit of perfect squares, and a little bit of solving all in one as an example. Okay, I've got 4 examples here of quadratics that aren't equal to 0. So what we have to do is we have to rearrange these equations first. We need them to be in this form basically every time. So we want them in form a, or something x squared plus something x plus a constant. So this one's a nice simple one. How am I going to make this equal 0? Well, I'm going to have to subtract 90 off both sides. So the x squared minus x minus 90 equals 0. Awesome. So now I can factorize. So this is going to be x minus 10, x plus 9 equals 0. And I can straight away see that my solutions are positive 10 and negative 9. The second question, okay, so now I've got 12x on the right hand side. Yes, you're correct in thinking we subtract 12x off both sides. So x squared minus 12x plus 27 equals 0. And the reason I put the negative 12x in between here is because I always want it in that form. Now I need factors of 27 that add to negative 12, which means they're both going to be negative, because only 2 negative numbers can multiply to a positive and add to a negative. And so I'm thinking 3 and 9. And there's my solutions. Since this equals 0, x is 3, x is 9. Maybe you could pause the video and try these two. What might you do so that you could rearrange these for 0? Alright, we're going to multiply both sides by x. That's going to get rid of this. But what's going to happen to the left-hand side? It's going to get multiplied by x as well. So we now have x squared equals 36 minus 5x. By multiplying both sides, we've got rid of this denominator, and we've increased this to a power of 2. Now it's just like one of these first ones. So we're going to have to add 5x to both sides, and we're going to have to subtract 36 off both sides. So we get x squared plus 5x minus 36, and this is now equal to 0. So we want to factorize this. We've got a negative number here, so it's x plus x minus. And I'm thinking 9 and 4, and it's going to have to be positive 9, because I've got positive 5 there, minus 4. Solutions are negative 9 and 4. I'll just do a line there just to separate this question. It's getting a bit cluttered. Alright, question 4. Hopefully you didn't just write x is 3 and x is 8, because that would be 0 equals 84, and that's not true. It's very tempting for us just to think, oh, yep, it's already factored, I can now solve, but it's not. It's factored, yes, but it's equal to 84. We need it factored equal to 0. Okay, this is quite a tricky one. What we're going to do is we're going to expand this out. X squared, then I'm going to get negative 3x minus 8x, so minus 11x, and I'm going to get positive 24 equals 84. Now I can subtract 84 off both sides. So x squared minus 11x minus 60 equals 0. And so I need factors of 60 that give negative 11. Hopefully I've done that correctly. So 6 and 10 won't work. What about 3 and 20? No, that won't work. What about 15 and 4? Those will work. So x minus 15 and x plus 4 are my factors, which straight away gives me my solutions 15 and minus 4. Easy as. Okay, what I hope you can do now is pause the video and give these rearrange and factorize problems a go, and then let me know in the comments how you went out of 8 and if you've got any questions about a particular problem. Cool, so hopefully you've paused and given that a go. I'm going to get started. Just to keep the video short, I might go through these a little quick, so just maybe rewind if you need to go through it again. So on this one, it's not equal to 0. We're going to have to subtract x and subtract 30 from both sides, bit of BS. So we get x squared minus x minus 30 is now equal to 0. I can factorize this, multiply negative 30, add to negative 1, x minus 6, x plus 5 equals 0. So x is 6, x is negative 5. Question 2, I'm going to add 3x and minus 10 to both sides. So I've got x squared plus 3x minus 10 equals 0. And so when I factorize this to x plus 5, x minus 2 equals 0, then my solutions are 2 and negative 5. Cool. Which makes sense. If I put 2 back in, that's 4, because it's 2 squared. So 4. And that's going to be equal to 2 going in here, negative 6 plus 10. Yep, so that's true. All right. Here's an interesting one. I got to take away 13x and add 6. So I got 6x squared minus 13x plus 6 equals 0. Common factor? No. So I've got to go first times last. Factors of 36 that give negative 13. I was thinking 12 and 3, but that's not going to work. 9 and 4, and they're both negative. 6x squared minus 9x minus 4x plus 6 equals 0. Factorize the right with a 3x coming out, leaving a 2x minus 3, and take a negative 2 out of this. Same bracket, there's one factor. Left over is another factor. One solution, 3 over 2. Other solution, 2 over 3. So that's probably one of the harder ones. All right. So first of all, on this one, I'm going to have to expand it all out. And now I'm going to have to subtract the 48. All right. I'm thinking 4 and 12 for this one. And the 12 is going to have to be the negative. Okay, so one solution is 12, one solution is negative 4. Positive 12 and negative 4 make these go to 0. Okay, here we go. Well, I might do this one a little differently. What you could do on this is expand this out to x squared plus 6x plus 9 equals 49. Subtract the 49 and get negative 40. Or what happens if we square root both sides? X plus 3 is going to equal positive 7, and x plus 3 would equal negative 7. Because obviously when you square root 49, 7 is a solution, and negative 7 squared is 49. So square rooting both sides of this one. I just wanted to show you something a little different, which means when I subtract 3 off both sides of this, x is 4, and when I subtract 3 off both sides of this, x is negative 11. If you expanded and simplified, you probably have this as a factorized form, x plus 11, x minus 4 equals 0, because that's how you would get those solutions. All right, so these last three look really scary and really messy to deal with. But all we have to do here is add 8x and add 7 to both sides. So 5x squared, adding 8x to this, well, that's going to give me negative 24x, and adding 7 to negative 12, that's going to give me negative 5. And that's going to be equal to 0. Do I have a common factor? No, I don't. First term times last term, negative 25. Factors in negative 25 that give negative 24, negative 25 and 1. So that's my split right there. 5x squared minus 25x plus x minus 5 equals 0. Put a wee line there just to help me focus on the left hand side where a 5 and an x can come out. And there's only a 1 can come out on this, so I'm just going to write that. I don't usually, but just to help you guys visualize what's happening. So 5x plus 1 is a factor, and x minus 5 is a factor. So one solution is obviously 5. Let's go with the easy one first. And one solution is negative 1 over 5. All right. Okay, this one's quite interesting. We've got x minus 4 all squared equals 2x plus 1 all squared. What we want to do is probably expand both sides. So maybe I'll just get the scrap paper and actually do that expansion for you. So we've got x minus 4, that's squared, and that's going to be equal to 2x plus 1 all squared. Well, squaring means multiplying by itself. Which means I'm going to get x squared minus 8x plus 16, right? Because I'm going to get negative 4x minus 4x to be negative 8x, and minus 4 times minus 4, positive 16. On this one, I'm going to get 4x squared, then I'm going to get plus 4x, because I'm going to get 2x times 1 and 2x times 1, plus 1, because 1 times 1 is 1. Okay, so that's the expansion done. So x squared minus 8x plus 16 is 4x squared plus 4x plus 1. Now, as you go through high school, some of your earlier math teachers probably teach you linear equations, and they get you, let's get the variable to the left hand side, but actually it doesn't matter which side you want your variables on. You've got to start thinking for yourself. So 4x squared here and an x squared over here. So I've obviously got more on the right hand side. So what I'm going to do is I'm going to subtract x squared off this side and this side, obviously. Got to do the same to both sides. Add 8x to both sides and subtract 16 off both sides. And that's going to kill all of this, make it 0. Which is going to leave me 3x squared. And I'm adding 8x, so plus 12x, and I'm subtracting 16, so minus 15. Oh, finally, I've got a nice one. I can divide everything out by 3, including the 0. So you know how when we factorised these ones, we took the common factor out the front. Well, very similar, but because it's now we're solving and it's equal to 0, we can actually divide 0 by 3, which is 0. 3x squared by 3, which is x squared. 12x by 3, which is 4x. And negative 15 by 3, which is negative 5. We can now factorise and solve. So x is negative 5 and 1. Okay, question 8. It's not too bad. We've got a bracket here, so we'll expand that side. And again, where are the most x squareds? They're on the right now. So we want to subtract x squared off both sides. And we want to subtract 12x so that this side equals 0. Which is going to give us just 1x squared on the left-hand side minus 12x plus 35 equals 0. X minus 7, x minus 5 equals 0. X is 7 and x is 5. Okay, that is quite a bit of maths. We have now just practiced 12 rearranging and solving equations. So we did these 4 first, and now I've given another 8 examples. And so that should be plenty of practice for you now to go away and try a few more online. Excellent.